Find the area bounded by the curves f of x equals negative x squared plus 2 and g of x equals x squared between 0 and 2. So for two functions f and g, where the function f is greater than or equal to g, so it's on top of the other curve for the interval where we're determining the area for, the area between the two curves is given by the formula. The area is equal to the integral between a and b of the upper curve f minus the lower curve g with respect to x. So you can see for this case we have two regions, one where g of x is above and one where f of x is above. So the area is going to be given by the integral of the first region, which goes between 0 and 1, and over that interval we have g of x being the upper curve, so we're going to have g of x and then we're going to subtract f of x, so the upper curve minus the lower curve with respect to x, and then we're going to add on the area of the second region, which is going to be the integral between 1 and 2, and this time we have f of x being the upper curve, so we're going to have f of x and then we subtract away the lower curve, which is g of x, and we calculate that with respect to x. So if we go ahead now and put in all the information we have that the area is going to be equal to the integral between 0 and 1, and g of x is x squared, and then we take away f of x, which is going to be negative x squared plus 2 dx. And then we add on the integral between 1 and 2, and this time we have f of x, which is going to be negative x squared plus 2, subtract g of x, which is just x squared with respect to x. And then if we clean this up, we find that that's the integral between 0 and 1. X squared minus negative x squared gives 2x squared in total. And then we have minus 2 dx, and then we have plus the integral, and we have it going between 1 and 2, and here we have minus x squared, which is going to give minus 2x squared, and then plus 2 is still there with respect to x. And we know that we can calculate this by finding the antiderivative. So for the first integral, we'll have 2x add 1 to the power divided by the new power, minus 2, and for any constant we introduce the variable, so we're going to have minus 2x evaluated between 0 and 1, and then we're going to add on negative 2x add 1 to the power divided by the new power to find the antiderivative, plus 2 and introduce x. So that's the antiderivative of the second integral, which we evaluate between 1 and 2. And now all we need to do is sub in the terminals using our fundamental theorem of integral calculus. So for this first square bracket, we're going to have, 2 times 1 to the power of 3 divided by 3, minus 2 times 1, and then we're going to subtract off from that the antiderivative with 0 substituted in, so we're going to have 2 times 0 to the power of 3 over 3, minus 2 times 0. And then that there is our first big square bracket, and then we add on our second big square bracket. So we're going to have negative 2, and we're going to substitute x equals 2 in first, so 2 to the power of 3 over 3, plus 2 times 2. And then from that, we're going to subtract away the antiderivative evaluated at 1. So we're going to have minus 2 times 1 to the power of 3 over 3. And then we're going to have plus 2 times 1. So if you go through, you find that this here is just 2 over 3, minus 2, minus, and that's 0, minus 0, and then we have minus 2 times 2 to the power of 3, which gives minus 16 on 3, and then that's going to become 4, so we're going to have plus 4, and then that gives negative, and then we have minus 2 times 1 to the power of 3, so that's just minus 2 over 3, and that's just plus 2. So if you go through and you do all the addition and subtraction through those brackets, you'll find that that is equal to 4 units squared, which is the area that's in this region here and this region here, which is the area bounded between the curves f of x and g of x between x is 0 and x is 2.